So good morning student. Today we will discuss about the Cmos inverter using the Microwind software. So this is the circuit of the Cmos inverter. Now in the Cmos inverter there is one PMOS and one NMOS. Okay. Now the source terminal of NMOS is connected to the ground and source terminal of the PMOS is connected to the VDD. Now the drain terminal of both the NMOS and PMOS are connected together, and here we will take the output Y. Similarly, gate terminal of both the NMOS and PMOS are connected together, and here we will apply the input A. Okay, so when the input A is 0, output Y is 1. And when input A is 1, output Y is 0. So this is our MOS act as a NOT gate. Okay, now we have to fabricate this using the Microwind software. So we will open the Microwind software. This is the screen of Microwind software. Now here there is a palette, and from the palette we will take the devices. So we will click on the MOS generator. We will select the NMOS. This is the width and length of the NMOS. We will take the by default whatever is the width and length, and we will click on the generate device and we will place the NMOS. Similarly, we will take the PMOS, click on the generate device, and this one is the PMOS. Here there is a stretch and move option. Using that we can align the MOSFET, whereas we have to always align both the MOSFET so that in order to avoid the zigzag. So now we have to connect the both gate terminal of both MOS. Gate terminal is made up of polysilicon. So we will select the polysilicon material and connect both gate terminal. Now we have to connect both drain terminal together. So we will use the metal one to connect the drain terminal. Okay. Now we will just take out some. So gate terminal and drain terminal we have made the connection. Now here there are the supply. Now this is the ground. So source of the NMOS is connected to the ground. So we will place here the ground. Now the source of PMOS is connected to the VDD. So we will take the VDD. This is the VDD supply and place on the our PMOS source terminal. Again, to the anvil, we also apply the VDD supply in order to avoid the floating. Then we will take the clock and we will apply clock at the input. Okay, so it is the input, whatever will be the default values, we will take as it is, and then we will assign the clock, and we have to observe the output. So here this is the output node, visible node, we will place on the drain terminal, and here it is the output Y, and we will assign the output. Now this is our circuit of the CMOS inverter. Now we will save this circuit, select save as, we will give the name CMOS inverter. Okay, so I will Cmos inverter. Okay, and we will save this circuit, and now we will run the simulation. So we will click on the run simulation option, and here we will get the output. Okay, so if you observe the waveform, A is green one is our input and Y is our output. So here when the input is 1, our output is 0, and when our input is 0, our output is 1. Okay, so this is the CMOS inverter simulation practical. Again, if you want the rise time, fall time, and the frequency, we will get here the rise time and fall time values. Okay, now this what we have done using the without the capacitive load. Now the next one is the with capacitive load. So again go to the palette. From here we can take also the palette, and we will take one capacitor. Okay, and we will place on the output side. Okay, on the drain terminal, assign the value, and again run the simulation. Save it and run the simulation. So with capacitive value also you can get the rise time and fall time. So this one is the waveform with capacitive load. Okay, so we will get the rise time 24 pico and fall time is 16 picosecond. So this is the practical based on the CMOS inverter. So thank you.